Hello everyone, I'm Mr. Shoemaker and today we're talking about heating curves. This is so that way we can make sense of the icy hot lab and we can figure out why we investigated the energy flow into the water. So for a heating curve, okay, so if you could please get out this graph sheet in front of you. So if you need one, please ask me to get one. And the first thing is we want to label this as temperature versus time. So your temperature axis will be along your y-axis here. So this will be temperature. And I think most of us have temperature in Celsius, right? So we can also go ahead and just put Celsius. If you had Fahrenheit, we can label that as Fahrenheit, okay? And then our time will go along this axis in seconds, right? And now everyone, what we need to do is we need to graph our data, okay? And so if you could maybe pause this video and graph your data points. Um, I think if you need some data, just let me know so I can give you some data. But this will start at 0 for you. I'm gonna go ahead and graph mine at uh, I'll count off by 20s. So 20, 40, 60. But you count off however you need to. So that way you can fit all of your data points on here, okay? We'll keep going. And then your temperatures will be here. I'll count off by tens. Okay, so please pause the video and go ahead and graph your data. And then I'll see you back. Okay, so I'm actually gonna go ahead and just draw my line here. So I think we should have a shape that looks like this. And this flat part up here is around 100. Okay. So it's just a rough sketch. But what you can see is that we should have a flat region around the beginning. And if you were able to get it to boiling, you have a flat region here. And what we also need to label is we need to label the which states of matter are present in each of these three distinct regions, right? The flat one, the slanted, and the flat. Okay. Now, if you think about what was going on at the beginning, well, you had ice melting, right? So what states of matter are present is you had a solid ice and liquid water here, right? So, and remember, um, so after that, it's melting here, right? But then what is the change? Why do we shift from this region to this region? Well, this is when that melting was complete. Okay, so if you marked it, I think we saw that, okay, the melting was complete, then our temperatures did start going up. So melting is finished, that means this is only liquid here, right? And this is just liquid water heating up um, in temperature, right? Then notice here it levels off again. Well, this is when the boiling started. So here you got liquid water and gas escaping, but nonetheless, we do have gas present there, right? So we'll say liquid and gas. Um, okay, now what we also need is we need some particle drawings on here. So here we want to show some solid going to liquid. So we'll draw two boxes or two particle drawings. Solid particles, are vibrating in place and they have a rigid structure. Liquid particles are free to slip and slide past each other and they are taking the shape of the container. Notice both of these are at the same temperature, right? So these are both at 0 degrees Celsius is the freezing point of water. Some of you may have had, a plateau at maybe 9, 10 degrees. And that's fine. Okay, just know that the actual freezing point is 0 degrees. The 9 or 10 degrees may have come from, if you were getting the temperature closer to the hot plate, it may have been warmer down there. Okay. Okay. Particle drawings for the next region. Here we need to draw some liquid water particles in here that are very cold, right? So they're not moving very fast. But then the energy is getting those particles to speed up. So we need to draw faster particles here. Maybe two whooshes, right? Okay, so good. And next, we have liquid going to gas. So we'll draw our liquid, um, slowly and sliding past each other, going to your gas particles here that are uh, independent of one another. Okay, now the last point we talked about with this is we said that, okay, what is the deal with these flat regions, right? Is because we know that the ice sitting on the hot plate, energy was flowing in the whole time, right? Was flowing into the beaker. So I'll just put that because that is an important point. But I think what our energy was doing is it was doing different things in each region, okay? So in this first region here, well, actually, let's do the middle region first, because I think we're more familiar with this, right? So in the middle region here, it's really clear we can see that the energy is going to speed up those particles, okay? So energy is speeding up particles. So let's add that to our heating curve, okay? But then what we can also see over here is that the temperature is not changing. So where's that energy going? Well, remember there's actually attractive forces holding those solid particles in place, right? It takes energy to move to overcome those attractive forces. And that's where our energy is going at first. It has to overcome those attractive forces. So here the energy is overcoming the attractive forces. And same thing over here. So let's put it for both. It's overcoming attractive forces. Okay, so everyone, please have this. If you need to pause, we want our heating curves to look like this, and we want to know what is present in each region. In the plateaus, that is your phase, those are your phase changes, excuse me. And in the slanted lines, that is when your temperature is changing and the energy is speeding up your particles. Okay, so everyone, once you have this, good one. And if you can please start on the scavenger hunt.